In section 12.4, we talked about the mathematics of finance, and we worked with this formula for finding the amount of an annuity. The amount of an annuity I can't spell. Let's see, A-N-N-U-I-T-Y is A sub I is equal to R. R is called the periodic rent. That's how much gets deposited or how much gets paid out to the person. 1 plus I to the nth power. I is the interest divided by the amount of compoundings raised to the nth. N is the number of payments completely made, minus 1 all over I. So in this problem, the annuity is going to be, the periodic rent is $400. That's how much you pay into this account. 1 plus the interest is going to be 0.08 divided by 2. The reason it's going to be divided by 2 is because this is paid semi-annually. That means twice a year. N is the number of total payments made. Now remember, this person's making 2 payments a year, every year for 10 years. So N is 20 minus 1 all over 0.08 over 2. Remember to keep I as the interest divided by the compounding. Now when you go and evaluate this in your calculator, the best way to do it is to first evaluate the numerator, then divide by the denominator. 0.08 divided by 2 is 0.04. Then multiply it by 400. And you'll find out that the amount of money after 10 years, when the last payment's been made, will be $11,911.23. Now another way of going about and doing this problem is to use the TVM solver on our calculator. The TVM solver can be found under Apps, Finance, number 1. Now, when using the TVM solver, which you can for every problem in the homework, you have to ask yourself what they're asking you to solve for. Since they're asking for the amount in the account at the end, they're looking for the final value, which means that I must know everything else. That means N is 20, because remember we said you make 20 payments. I you put in as 8, because I in the TVM solver is already the percent. PV is the previous value. When you're putting money into an account, you usually start at 0. PMT is payment. In this case, I know what the payment is. It's $400. FV is what we're going to solve for in a minute. And then PY is payments per year. This particular account, you're going to make 2 payments per year. When you change PY, it will also change CY. We won't worry about that. Once you put in all this information, you need to get your cursor back to FV. And then hit alpha, enter. And this answer will pop up. In this next example, this time we want to find out how much money should be invested every month. That means find R. At 12% per year compounded monthly in order to have $4,000 in 18 months. Well, now I know the final value is 4,000. What I want to find is the periodic rent. 1 plus the interest is 12%, that's 0.12. And we're going to compound this monthly, which means we're going to divide it by 12. We want to put money in the account every month for 18 months. That means we're going to make 18 payments. Now, 0.12 over 12 is 0.01. So if you want to change that to 0.01, you can. And again, how are you going to do this? Well, first I would evaluate this, and then I would divide that answer by this, and then I would do 4,000 divided by the previous answer. Now the way you do that on the calculator is you use second negative sign. That's where A and S is. And what it'll do is it'll divide 4,000 by whatever you got over here. And you should find out that it should be about $203.93 a month. In the TVM solver, N is 18, I is 12, PV is 0, because remember, if you're putting money into an account, you want to start at 0 and work your way up. Payment is what we're going to find. FV is 4,000. And payments per year are going to be 12. And then you would get your cursor on payment and hit alpha solve. And you'll get this answer here. Let's look at a different $10 million in the California lottery, and the amount is paid in yearly installments of $500,000 each year for 20 years. What's the present value of his winnings? Assume that he can earn 10% interest compounded annually. Present value is a little bit different formula. What we're doing, instead of putting money into an account, we're taking money out of an account. So the formula for the present value of an annuity is the periodic rent times 1 minus 1 plus the interest divided by the compounding, raised to the negative number of payments, divided by the interest divided by the compounding. So in this particular problem, the periodic rent, they told me that they pay me in installments of $500,000. That means every time they give me money, they give me $500,000. That's my periodic rent. 1 minus 1 plus 0.10 divided by, well, how often do they give me this money? Well, once a year. Raised to the negative, how many payments are they going to give me? Once a year for 20 years is going to be 20 divided by 0.1 divided by 1. Now 0.1 divided by 1 is still 0.1. And again, what would I do to evaluate this problem? I would first do this. Don't forget that this is negative 20. Then I would divide it by 0.10, and then I would multiply by 500,000. And you're going to find out that the present value of the winnings is $4,256,781.86. Since if you want to do this in the TVM solver, what you're doing is you are solving for the present value, because you're paying this down. When you're paying something down, the final value is going to be 0. Next, a student wishes to buy a car. She can afford to pay $200 a month, but has no money for down payment. This should say, but. If she can make these payments for 4 years and the interest rate is 12%, what purchase price can she afford? Well, remember, we're paying this down, so we're going to use this formula. Anytime we're, not 20, that's a negative n. Anytime we're paying something down, we want to use the formula that has the negative n in it. We want to find out what her purchase price is. So the periodic rent, we know she can pay $200 a month. 1 minus 1 plus, the interest rate is going to be 12%. And car payments are made monthly. Raised to the negative n. Well, she makes 12 payments a year for 4 years. That's going to be 48 payments over 0.12 divided by 12. Again, evaluate the numerator first, then divide it by the denominator, then multiply by 200, and you're going to find out she can afford a car that's $7,594.79. Again, if you're using the TVM solver, what you're doing is you're solving for the present value. A couple borrows $100,000 at 9% interest as a mortgage loan on a house. They expect to make monthly payments for 30 years to repay the loan. What is the size of each payment? Well, if you want to know what the payments are going to be, you can rewrite the present value of an annuity formula to solve for R. And this is what it would look like. So we know that the interest is 9%, and the because mortgage payments get paid back monthly, we're going to divide that by 12. Times the present value of the annuity, well, they got a loan for $100,000. We're going to divide that by 1 minus 1 plus 0.09 over 12, raised to the negative. Well, the payments are monthly for 30 years, and 12 times 30 is 360. So again, what would you do to solve this? I would evaluate this first, then I would divide it by this, and you'll find out that the monthly payments are $104.62. Now, if you're using the TVM solver, what you're going to be solving for in this case is the payment. Remember that when you are paying back something, like you borrow money for a car, you borrow money for a house, you're getting money from a lottery annuity, you're going to be using the present value of an annuity. When you're putting money into an account, that's when you're going to use the formula for A sub I.